Hey guys, we're back again in the middle of talking about energy. Now we're moving on to thermal energy or heat energy. It is a form of energy like in earlier chapters with potential energy of spring or gravitational potential or kinetic energy. And it still has units of joules. We could also have it in calories too, but we've been trying to stay in the idea of joules. Now in this problem here we're going to add some heat or find out how much heat find out how much heat is needed to increase the temperature from 10 to 50 degrees centigrade of, let's see, 10 kilograms of water. Alright, and if you have me in class, we've done this problem similar a lot. So let's do that. Now we do have a temperature change. We also notice that we are not going above or going beyond the boiling or freezing points of water, so it's staying liquid the entire time. So we can go through Q equals mc delta T. That's the equation we can use here. It's going to be mass, specific heat value, change in temperature. So we have 10 kilograms. The C value for water is 4186. The change in temperature, how much did that change by? It changed by 40. Now I'm not going to put in the plus or minus. I'm just going to say by how much did it change, because here we're adding heat. To raise the temperature we have to add heat, so it's implied that it's a positive number. So that's going to be 10 times 4186 times 40 equals 1,674,400 joules. If we were to put all that energy into that 10 kilograms of water, the temperature would go from 10 to 50. Now if I wanted to know how much heat had to be removed to take it back from 50 to 10, I could calculate that. There's 10, there's 4186, again it dropped by 40. You'd find out that you get the exact same number. Okay, 1,674,400 joules. But it's implied that since we're removing it, remove, and here's where we add, or added, we get the exact same number, but in the negative. Now we should look at this and say, alright, if we put this much into to raise the temperature, and we take the exact same amount, it'll just reverse the process. So that's sort of just a verification there, a double check of what's happening with that problem. Okay? Now let's just look at another material real quick here. What if we have iron, which I think off the top of my head, iron C value is around 450, and we did the same thing for the same amount of iron. So that's 10 kilograms. So that Q is going to be 10 kilograms times 450 times 40 degree change. So 10 times 450 times 40 is 180,000. And I would say only 180,000 because in comparison to what we needed to heat up the same amount of water, it's about 1/10, or yeah, about 1/10 of it. Now that is mainly due to the difference, the very big difference between the C values. C has a higher specific heat value, which really means in my mind is sort of like a temperature inertia. It's harder or takes more resistance to heat up, but once it's hot, it takes more time to cool off. Now if I had that water inside the pot and I wanted to know the total energy for the water and for the iron, I would just add those two numbers together, and I don't think I'm going to have time to do that. And we come up and there would be an answer for a question that says, what's the total energy needed to heat a 10 kilogram pot filled with 10 kilograms of water, if that was our problem. So that would give us that number there, whatever that comes out to be. This number plus that number gives us that number. Alright, helped you out with Q equals mc delta T. We'll see you in the next video.